Well, welcome everyone to the Canadian Sleep Research Consortium Sleep Education webinar series. I'm very pleased today to have Dr. Mary Cascadon with us to talk about the understanding of the biobehavioral underpinnings of teen sleep, the implication for school starts time. I'm sure all of you know about Dr. Cascadon's work, but I'll say a few words to outline just a few of the milestones of her career. So, Dr. Cascadon is the director of the Chronobiology and Sleep Research Lab at Bradley Hospital, and she's a professor of psychiatry and human behavior at the Alpert Medical School of Brown University. Mary is a pioneer in the study of sleep in children and adolescents and a leader in the field of sleep and circadian science. Her research has examined the interrelations between the circadian timing system and sleep-wake patterns in children, adolescents, and young adults. And her findings have raised public health awareness regarding the consequences of insufficient sleep for adolescents, as well as concerns about early starting school time. Many school districts have introduced later school start times for middle and high school students as a result primarily of her work. She has many accomplishments. I'm just going to mention a few more here, but all of you know about the multiple sleep latency test. Well, Mary developed and validated that well-recognized measurement in her years at Stanford. Mary has also served in several leadership positions, including as a member of the National Commission of Sleep Disorders Research. I remember going to Capitol Hill when Mary was there with Bill Dement, and I had brought a patient of mine when I was in Richmond, Virginia, to testify there. But that was very influential to create subsequently the NIH Sleep Disorders Research Advisory Group. Mary has also been the president of the Sleep Research Society and has also had leadership roles, many leadership roles in the American Academy of Sleep Medicine. And she was also the founding editor-in-chief of the journal Sleep Advances. Mary has played a major role in training generations of students, and to recognize that, the Sleep Research Society has even created an award in her name. It's called the Mary Cascadon Outstanding Education Award. She has received many other awards, and I'm just happy to have her with us today. It's a great honor to have Dr. Cascadon with us. So she will talk about sleep in children and teenagers and put that in relations with school start times. Mary.
Thank you very much. It's really an honor for me and a pleasure for me to be speaking to my northern neighbors and not to be up there in the freezing cold. I guess it's not quite freezing. And you have Thanksgiving soon, right? Is that next week? Well, I'll wish you an early happy Thanksgiving. So many folks down here who they'll marry Canadians in case our election goes the wrong way. So they have an option to get out of town. Anyway, we're hoping election down here goes well because it impacts not just us, it impacts the entire globe. So we'll see. Meanwhile, is it my turn to start now, Charles?
Yes, it's your turn, Mary.
Okay, so let me share my screen. And I was asked to lead off with, and I'm very happy to do so. This is my slide deck. Share. Here we go. So I was asked to lead off with the Brown University land acknowledgement statement. And, I was first introduced to this philosophy, I guess, when I was spending time in Australia, because every event down there does begin with a land acknowledgement statement. So just so you know, that Brown University is located in Providence, Rhode Island, on lands that are within the ancestral homelands of the Narragansett Indian tribe. We acknowledge that beginning with colonization and continuing for centuries, the Narragansett Indian tribe have been dispossessed of most of their ancestral lands in Rhode Island by the actions of individuals and institutions. We acknowledge our responsibility to understand and respond to those actions. The Narragansett Indian tribe, whose ancestors stewarded these lands with great care, continues as a sovereign nation today. We commit to working together to honor our past and build our future with truth. So that's the Brown acknowledgement of where this place actually came from. As Charles mentioned, my topic today will be to explain some of the underpinnings of teen sleep and how they impact or what their implications are for school start time. So this is kind of, for me, the central observation about teens, that adolescents who were once such champion sleepers, eager to start the day, waking with joy in their hearts and a song on their lips, begin to struggle against going to sleep at night and struggle to wake up in the morning. This is not a new phenomenon. Actually, this is a paper by Terman and Hawking in the early part of the 20th century, where they note that it may be that adolescence tends to change the individual from the vesperal to the matinal type of sleeper. In other words, just what we saw, they instead of easily falling asleep in the evening, they now want to sleep in the morning. And it's also been noticed in popular, this is actually a mother's perspective of this. My 13-year-old son's sleep is a phase-shifted nightmare. That too seemed to happen overnight. I spent his early childhood wishing I could sleep past 5:30 on a Saturday morning, and now I spend most of Saturday trying to get him out of bed by dinner. Those of you who have teenage children may have experienced that. And then I found this to be an interesting quote from a novel by Mary Gordon. This is a teenager speaking. My adolescent sleeps were long, dark, and sullen. Never once in all those years did I wake of my own accord. So this happens, and it is common. And it is a challenge for teenagers and their families struggling to get up in the morning, often for school. So I want to talk about circadian timing, the clock, the sleep-wake homeostatic process, which I'm conceiving for you today as an hourglass, some of the consequences of these processes, and we'll talk about school start time. Do you all have the yellow school buses in Canada?
Yes.
It's not just Southern North America. So just to start, I'll remind you or introduce you to the two-process model of sleep regulation. And we're talking about how these processes change during adolescence. So they're independent processes. One, process S, where sleep pressure rises during the daytime and falls during the nighttime. And you can think of that as the hourglass filling with sleep pressure and then emptying as we sleep. Process C, that sleep pressure oscillates daily, circadian rhythm. So it's driven by the clock in our brains. Now, although I mentioned they're independent functions, they also interdependently work to help us maintain our awake during the day, even though, excuse me, the hourglass is filling with the sleep pressure, but our clock is sending a late afternoon, evening alerting signal to offset that sleep drive so we can stay awake all day long and into the evening. So let's look at circadian timing. I want to introduce, for those of you who may not be as familiar, some of the ways that we look at and measure the circadian timing system. First, the biological clock, it's complex. So one of the ways we describe it is by measuring phase and determining phase. So that's an instantaneous point on an oscillation, just shown here as a sine wave. And the point pointed out here is acrophase, or the peak phase, but we could pick any point and call it a phase. So for example, here we could say, oh, trough phase, or, we could say the beginning of the rise would be a phase. So that's one way of describing the clock. Another way we describe it is with a period, which is the time it takes for a given phase to reoccur. And the period is measured in living animals. One way is here's a mouse, put them in a box, don't give them any light signals, and the clock keeps ticking. This is about 3 months. And the period of this clock is a little shorter than 24 hours. So you can see that he gets up on his wheel at the same internal time every day, but reference to external time, the period of that recurrence is about 23.5 hours. So we have phase, we have period. We can also look at the amplitude of the rhythm and measure that as a way of describing the circadian timing system. And we can look at the response to light signals, which are the major Zeitgeber or time giver for the clock. And so we can create what's called a phase response curve. And the general principles of the phase response curve is that the rhythms are delayed by the light stimulus that's occurring early in the night, and they're advanced or brought earlier when the light stimulus is given late in the night. So it's phase dependent. So now how would we measure these things in the teen clock? Well, in terms of phase, we look at phase preference, or another name for it is chronotype, and I'll show you in a minute what that looks like. But the preference is like questionnaire: when do you prefer to study, or when do you prefer to be active? Or, are you a lark? Are you an owl? The intrinsic phase, so we can measure the clock phase using a biological signal, which I'll show you in a minute. Then we can measure intrinsic period, but not by putting the teenager in a dark cage with a wheel or a bicycle to work on. We have a very much more challenging and complex way, but we can expose that intrinsic period of the circadian rhythm. And I didn't emphasize this circadian, that word is important. It's our rhythms are not exactly 24 hours. They're about 24 hours. And so we have to, uncover ourselves or our participants from daylight and darkness in order to measure that. We can also measure the phase response. What happens if you shine a light? How much does the clock phase move? And we can also measure the amplitude. So I'll show you examples of all of these and what happens during adolescence. So just keep in mind this, our central observation, that the teens' sleep timing gets later. Later. Just so you know, this isn't just people. This has been observed in other species as well. So yes, people and monkeys, and my favorite rodent, the Octodon dagus, lab rats, lab mice, the fat sand rat. Most recently, I saw the marmoset. and I know people kind of get curious about what does a fat sand rat look like? So there's an image of your prototypical obese sand rat. He's pretty cute though. He's cuter than most rats. Anyway, so let's look at the measures. So chronotype, this was a measure developed by Till Roenberg, which basically is looking at on days when you don't have any, external forces saying this, you need to go to bed by now, you need to wake up by now. What is the middle of your nighttime, of your sleep time? So it's the middle of sleep on these free nights. And here we see you call this the adolescent phase, the second decade. And you can see that this measure is moving markedly later across the second decade for boys and for girls. I think more so for boys than girls in Till's data. And he uses to identify what he calls the biological marker for the end of adolescence, this inflection point here. So this is, I think it's a very interesting measure. And one of the things that I think about when I see this is, wait, it's the middle of sleep, but midnight is the middle of darkness. Why isn't midnight the middle of sleep? Well, because you can't see the lights in my office, but we have other ways of telling us when it's light and when it's dark that don't necessarily rely on sunrise and sunset. So, in the 21st century, our mid-sleep phase is very far from midnight, even as we get older. So we've done things to our behavior and our clocks. Oh, and in daylight saving time, yeah, it's different. Midnight is not the middle of darkness because we've done other things to our clocks. So again, from Till's work, the behavioral pattern is very clear. The timing of sleep moves later across adolescence. So let's look at a phase marker. So I said we can measure a biological phase, and we do that by measuring melatonin. Now, melatonin rhythm rises in the evening, is high all night long, and then falls in anticipation of waking up. We can only measure it in our labs, or we're now doing it at home, if we're collecting our saliva samples, which is how we measure it, under dim light conditions, because the synthetic pathway from serotonin to melatonin, the enzyme that converts serotonin to melatonin, its function is suppressed by light. So we need to have our participants in dim light. And so our phase marker is shown right here. It's the melatonin onset phase. So when the rising melatonin levels begin. And that's a really very nice, very reliable marker of the internal biological phase. So when we look at that, this is just a plot from an 8-year-old boy showing we started collecting the saliva at about 1800 and measured it until 1030. And here would be where we would compute the onset phase. So we use a threshold of 4 picograms per milliliter. So this 8-year-old boy had a pretty early melatonin onset phase, leading his sleep by about an hour to an hour and a half. So when we look at adolescence, this same measure, so here's our 8-year-old would be about here. And I should mention, Tanner stage is a way to assess maturation, looking at, during adolescence, looking at secondary sexual characteristics. So you look at we don't the doctor looks at the child and rates them on their secondary sexual characteristics. So Tanner stage 1 is prepubertal and Tanner 5 is mature. This will come up again. So we see this developmental change occurring. So again, here's our 8-year-old who hasn't started marching through puberty up until we hit mature age kids. And you can see a delay of roughly, almost 2 hours across this time. I should mention these are times sort of truncated. So when the teens are staying awake later, as Roenberg showed us, then they're getting evening light, which pushes their phase later. This is an example of that phase response curve. Evening light pushes later, delays. Morning light, which teenagers aren't getting because they're sleeping in, or they put blackout curtains on their windows so the light doesn't come in the morning, or they move to the cellar and live in a cave because they don't want these light signals. So when they stay awake later, they're getting these evening signals, which help with the change or the delay in sleep. So this is a behavioral phenomenon that affects their circadian timing. This is an example in a non-human animal. This is a lab mouse, white mouse, looking at that phase response curve in a juvenile mouse compared to an adult. And so here's nighttime. You can see that the signal that's occurring in the nighttime is creating a much larger delay in those rhythms in the juvenile versus the adult mouse. So again, contributing, if we can infer that this same process may be happening in humans, contributing to that push for later sleep. Another push that we think may be helping this is that period lengthens. So here are data. I said we could measure period, and we do it in the lab by putting the kids on a 28-hour day in constant dim light so we can measure their melatonin the whole time. Their clock, which is about a day, about circadian, can't keep up with the 28-hour day. So it runs free, just as the mouse clock did when it was in constant conditions of constant darkness. And here we see our adolescents that we've studied versus adults that were studied in Dr. Seisler's lab in Boston. And you can see the adolescents in general have a longer circadian period, which can help drag, if you will, the clock to later timing. And then we mentioned amplitude. So these are data that Stephanie Crowley put together from our studies. Again, here's our pubertal stages, looking at the amplitude of this melatonin curve across the night. So these are kids we kept up all night, and they were fine because they were in the lab and we play games with them and so forth. And you can see Tanner 1 has the highest amplitude, and then it goes down. And then the mature kids, you can see that the amplitude is cut by maybe a third to half. So to summarize what happens to the biological clock and teens, 1, we see phase delaying. So we see that with chronotype, a behavioral measure. We see it with melatonin, a biological measure. And I'm sorry, we also saw a change in light sensitivity in that mouse example. The period longer, the day, oh, here it is. The delay response to light is greater. The amplitude shrinks. And so the result of all of that is, from the biological and behavioral phenomena as they change during adolescence, late nights are favored. That said, so too are late mornings. So all of sleep would be shifting were we to allow it to. And parents have a great mission often to try and not let this happen. And it's a struggle. It's a struggle. Well, so let's look at the sleep-wake pressure system, otherwise known as the sleep-wake homeostatic system. Back to our hourglass. Just again, a little introduction, reminding us that we have the qualitative measure that we're looking at when we look at sleep. So that's the sleep stages across the night, shown here in this hypnogram. And then we can do a quantitative analysis, shown here with a spectrogram across the night. Here are the lower frequencies and higher frequencies across the night. So those of you who are sleep savvy are intrigued by the spindle stripe here at about, excuse me, 13 hertz. And here we see our slow wave sleep at the bottom. And then we can look at slow wave EEG power taken from the spectrogram. Excuse me, look at that across the night. Excuse me a second. So one of the things that you can see from the hypnogram is these deep sleep stages occur mostly in the beginning of the night, which is paralleled by the slow wave activity, which is greater at the beginning of the night and then falls across the night. So again, we have these two ways of looking at it: the slow wave sleep, the slow wave activity in the EEG, and another way of looking at it is the sleep propensity, the speed of falling asleep. That's the MSLT that was mentioned earlier. So what happens during adolescence? Well, first, before we get to sort of the regulatory processes, it's really impressive to me how the look of sleep changes during adolescent development. So here are stage 2 EEG, stage 4, and REM sleep EEG in a prepubertal 10-year-old. And you can see, you know, our benchmarks are very clear. There's a K complex, sleep spindle, high voltage, slow waves, relatively low voltage, mixed frequency. But now we have a 15-year-old who's mature, and holy smokes, it's a very different look to it. But we still see our sleep spindles. We still see our K complexes. We still see relatively high voltage, slow waves in stage 4. And the REM sleep EEG does have that relatively low voltage and mixed frequency activity. So the relatively low obviously is relative to the other stages, but this is phenomenology. So, and it's most likely related to a brain change that's happening as programmed synaptic pruning that occurs across adolescent development, and that will diminish the amplitude of the signal because it's diminishing basically the building blocks that create the EEG. So here again, we have this is phenomenology again. Here's the same child recorded about 2 years apart when she was prepubertal and postpubertal. And you can see in the hypnogram, you see the change in the amount of deep sleep just across those 2 years. You can also see it in the slow wave activity power, also markedly changed, markedly reduced across those 2 years. Again, we see that and we know that's going on, but what's happening to the biological regulatory process? Well, with the help of Oscar Yaney and Peter Ackerman, Peter is the, what would we say? He's the guy who does the modeling, the mathematical modeling. And they looked at our data from children who were either pre or early pubertal or late pubertal. And we studied them after a night of normal sleep and then taking away that sleep. And what they showed was that the emptying out of our hourglass here, shown here, doesn't change from these pre and early pubescent kids to the late pubescent kids. So this delay time constant is a marker for the speed of this decline. However, when they looked at the filling up, if you will, across the daytime of our sleep pressure, measured with the rise time constant, they saw that it's about 3 hours longer in the post-pubertal adolescent than the pre and early pubertal. So that's showing that parts of the regulatory process change and parts do not change. And the important thing to note, well, I'll go over it in a minute, what I think it means. And I also mentioned we can look at the propensity or the speed of falling asleep. So this is that MSLT. And you can see here the dark circles are prepubertal, the white circles, the Tanner 5 kids, the postpubertal. And again, after about being awake for about 14 and a half hours, we see these two curves diverging. So the Tanner 5 kids, the postpubertal kids, are able to stay awake longer in the MSLT than Tanner 1. I mean, eventually they'll fall asleep. And again, there's separation here at 16 and a half hours awake. By 18 and a half hours awake, everybody is in what we call the twilight zone, falling asleep within 5 minutes. And the two curves converge at that point. Because it's really, really hard to stay awake, regardless of whether you're Tanner 1 or Tanner 5. So we're looking at the hourglass and teen sleep. So emptying the hourglass, that's what's happening during the night, that actually doesn't seem to change across adolescent development. My interpretation of that is that the same amount of sleep is needed because we're emptying out at the same rate. But filling the hourglass across wakefulness is slower in the older teens. So it's easier for them to stay awake longer, even though they need the same amount of sleep. And remember, their clock is pushing later, so they just climb onto that because it's easier to stay awake longer, even if we made them get up earlier. So again, late nights are easier to achieve and to send that wrong signal to the phase response curve, if you will, but they seem to need the same amount of sleep. So teens are really put in a bind. And this was the study that really, for me, sort of made the point that school start time is really harsh on teenagers. These are kids who were in grade 10 and they had to be at school for a 7:20 school start. And so we monitored them with the activity monitors for all their school nights. They averaged about 7 hours of sleep a night, which is about 2 hours less than they need. And you can see that especially in this would be second period, if they started at 7:20, these kids are basically in the twilight zone. They get a little better across the day. But more remarkable to me was they had REM sleep onsets. Half of them had REM sleep onsets, mostly in that what would be second period. So they're falling asleep in 2, 3, 4 minutes and going right into REM sleep, which is not the way that we usually fall asleep unless, it's not an epidemic of narcolepsy. We checked that out. These kids are being tortured by what the school clock is doing. And you can see here, the kids who had these REM onsets were also had a later time of their melatonin onset. So their circadian timing was different. And they were being asked to be in school when, according to their biology, they should have still been in bed sleeping and getting that REM sleep in the right place, which is in their beds. So there's just a little bit of summary of some data about the school starting times in the United States. And we've noticed over, the last decade or so, there's a rising global concern about this issue of teen sleep and school start time. I spoke in Saudi Arabia, in, Australia, of course, England, Dubai. I'm so lucky I get invited to go to these places. And people are so nice. At any rate, it's a problem. It's not just in the States, although it's probably worse in the States than many other countries. But is it fair? Is it fair? And is it more of a challenge for certain kids who have live in certain circumstances with other challenges? Is it fair to them? So kids in lower socioeconomic strata, there's lovely data showing when the school start time was changed, those kids had a greater benefit from the later start time than the kids who had, higher socioeconomic status, or kids with learning or behavioral health challenges, or various racial, ethnic, religious minorities. And of course, the children who have the longer commute to get to school, they have a greater disadvantage with this. So the early start, it's not just early start, which is bad, but it's the part where sleep gets compressed because of that. So this is just a, sort of a model showing what I call the perfect storm. So there's the biological pressure from the slower sleep pressure buildup, the circadian rhythm delays. There's external pressures as well. So competing activities after school, studying, homework, etc. And screen time and the engagement with screens. Those are all pushing sleep later. And then we have these things pushing sleep offset earlier. So the early school start time and early morning activities before school, I don't know if the same thing happens up there that happens down here, where the ice time for the high school hockey team is the earliest time that the ice rink is open, because they have last pick, I guess. At any rate, those kinds of things push the wake time earlier, and you can see the opportunity to sleep is shrinking. And that's, the major issue is they're getting too little sleep. And kids who are more susceptible have greater problems. So one that, is universal if you haven't had enough sleep is being too sleepy. That and inattention can affect learning, can affect our behavior regulation in kids. And although one of the sort of I'm so sorry, natural things that teenagers do is risk taking. But when they haven't had enough sleep, it gets out of control. Will you give me 1 second while I wet my whistle? Talking too much. Sorry about that. So teens are risk takers by nature, but that gets out of control and it leads to increased use of substances. Of course, I include caffeine, so they'll use more and more caffeine, which not only has a learning impact, but taken late in the day, it will push your rhythm later as well. So it affects circadian timing. Auto crashes increase mood, depression, suicidality. All of these things are much more evident in teenagers these days than they have been for a while. It's not all sleep, obviously, or school start time, but there's it's almost epidemic proportions in these days. And then we have all of these other metabolic changes that can lead to some medical issues. So to go back to where I started to quoting novels, I think many adolescents might agree with what Robert Heinlein wrote in his novel, Time Enough for Love. Waking a person unnecessarily should not be considered a capital crime. For a first offense, that is. So when we're waking those kids unnecessarily, it's a risk for the parents sometimes as well, I think. So for teens, sleep is not a waste of time. It's not a waste of time for us grown-ups either. Because I'll tell you, sort of, I've made a little, I don't know, call it a meme, a little equation to define that. For me, the bottom line is less sleep doesn't really give you more time because you become much less efficient in using your time for studying, or, you know, doom scrolling, or whatever it is that you're doing. So I have lots of people to thank: undergraduate students, graduates, postgraduate trainees, colleagues, my mentors, funding agencies, obviously, and the participants and their families who've done so many things to help us do our research. So thank you all. Thanks for having me. I guess, is it time for questions now?
Yes, indeed, Mary. Thank you so much for this great talk. And I'm going to take the privilege of asking the first question, going back to your earlier comments about the biological sex differences in terms of timing of sleep. How, and we see that during the teenage years, and then it seems to remain there throughout the lifespan until about the 50s. So is the difference explained primarily by biological hormonal factors, or are there other factors, including behavioral ones, explaining that?
Yeah, it's a great question, Charles. I think, shall I stop sharing now?
Yes,
Okay. So I think that much of it is behavioral, although Till, you know, is calling this the biological marker. A lot of it is behavioral. And so boys tend to stay up later in many times because they're allowed to. So parents let, you know, male offspring have fewer restrictions in that regard. They can go out with their gang or their friends, whereas the daughters are kept more restricted in what they're allowed to do. So I think for me, that's behavioral. But I think that is also reflecting this push for later, this biological push. Now, we have not found many, part of the issue is we don't have enough subjects in our biological studies, but we haven't seen big sex differences. Where we see it, though, is in behavioral outcomes. So, you know, we did a survey, which we've repeated many times, asking, when do you go to bed, when you wake up, you know, and what do you do on the weekends? And on school days, girls, more often than not, are reporting getting up earlier than boys. And one of the thoughts I've had, which is a little bit sexist, I guess, is that the girls get up earlier, not because they are naturally waking earlier, but because getting ready for school takes them more time due to their concern, maybe greater concerns about their appearance and grooming and so forth than the boys may have. Although I think that's even changing these days, where girls are becoming less concerned and boys maybe more. So that may be leveling out as well.
Okay, thank you. So it's open for your questions now. Anyone with questions for Dr. Cascadon? Yes.
Is Nicola driving her car?
I guess someone is.
Oh
Yeah.
my goodness. And is that the North Star? Is it still dark there? Anyway, sorry. She must live out west.
Jean-Philippe.
Thank you, Marie. Good presentation. I think in Canada, when we look at high school start time, we're doing pretty well. I think most of them are after 8:30.
Oh, great.
But the big concern, as you probably know, with teenagers is screen time. So excessive time spent on screens impacts their sleep, their mental health, and then the government doesn't really know what to do. Recently in Ontario and Quebec, with public health policies, they restrict no cell phones in the school setting, and Quebec is contemplating to ban cell phones in high school as well. So I just want to know, with your experience, what you think about how we should go about screen use and having a better relationship with our screens and during teenage years and the impacts on sleep and mental health and other aspect as well. So how do we control that?
Well, I don't have the answer to that, but I think, part of it is modeling by the parents or the caregivers, because a lot of time parents are also, on their screens much more than many of us would think is appropriate. They've got their phones on during mealtime with the family, or they stay up past what should be their bedtimes. But it's interesting, the teenagers, a lot of times parents are in bed sound asleep before the teens. They don't even know when their kids go to bed, much less able to monitor what they're doing. I've often had the idea, nobody's implemented it yet, of the family lockbox for technology. So everybody puts their phones and their tablets and so forth in the box. It stays locked till 6 o'clock in the morning or something, so that not only the kids but the parents aren't doing the screen time so much. But with the adolescents, there's a push down here. There's actually even some lawsuits against TikTok because they're saying it's designed to be addictive for children and adolescents. And I don't know if that's true, but that's part of the problem. Kids they'll sit there and they'll scroll through these things forever. And then some of the content, it's not just having the screen, it's the content that sometimes is really inappropriate, and brings some of those feelings of loneliness and anxiety and depression, and even leading to suicidality. So you've identified, something, a behavioral that's pushing even later in many of these kids. I'm so glad I was born when I was and didn't have this. But I also remember when I first heard about the internet, my first thought was, oh my God, it can't be on 24 hours a day. We need to have a rolling blackouts of internet across the nation and the globe, so that people can't access it when they should be sleeping. We're diurnal animals. We should be sleeping, not on the internet. But of course, that was just my silly little idea.
Thank you.
Thank you. Who's next? Well, I have another one. Oh, Nicholas. Go ahead, Nicholas.
Thanks for your talk. It was very interesting. I'm curious if we kind of think about moving forward and changing the policy, and we think in an ideal world, if sleep researchers were the ones that called the shots, and say we started school start time at noon, in an ideal world, would that really, do you think that would really change things, or do you think that would kind of anticipate that the teens would then just phase delay even more and then start their REM cycle even later, and then it doesn't necessarily solve the problem? And I'm thinking maybe because it's trying to process the previous day, which started later anyway, and then the cycle continues.
Well, in schools where they have changed the school start time, not to the extent that you're suggesting, the fear is always that the kids will just stay up later. And that's not what happens or what has happened when they've done it. I as a sleep researcher, if I controlled the world, I wouldn't have school start at noon. Uh, you know, and I would also not have daylight saving time. And I would also have, you know, people be more exposed, if you will, to natural daylight and darkness. Now, obviously, so I gave a talk, where was it one time? The Oilers. What town are the Oilers hockey team in?
Edmonton.
Yes, so I gave a talk there one time, and the folks there were saying, well, but it's dark in, you know, in December. It's really dark here. It doesn't matter when we would have school start time. It's going to be dark because it's so far in northern latitudes, and there are cities and towns even further north. I can't cope with them and help them, although now that we have artificial light, you know, we can sort of manage, but it's being more thoughtful about regulating what we're doing, not regulating so much as being mindful of what we're doing and how what we do sort of impacts what we're able to do. And I think for me, you know, the school start time, the worst part of it is kids aren't getting enough sleep. We're not giving them the time they need to get adequate sleep. And it's the insufficient sleep that's leading to a lot of these down the line problems and issues and concerns.
So Mary, maybe as a follow-up question to Nicholas, we know a great deal about what's the impact of early school start time on attention, sleepiness, school performance. What do you tell people when you go around the world and you recommend that they change their school start time to a later time? What's the evidence that this has a significant impact on different endpoints?
Well, some of the endpoints, you know, are so insidious that they are occurring over, you know, not just days and weeks, but months to years. And so not all of those have been obvious. And a lot of the data are cross-sectional.
Mm-hmm.
And so, you know, we can't really say too much about things. But Charlene, the other thing I'll mention is I have a very Western industrialized, you know, nation view of these things. When I was speaking, it was Abu Dhabi. So I was challenged by, you know, if we push school start time later, we're pushing it into the heat of the day more. I mean, so there are not just latitude climate issue or geophysical issues, there are climate issues that are of concern. And so he said, no, this isn't a solution for us. We need to have a different solution. And even in Canada and the US, the solution needs to be different in different school districts in different cities. I mean, if there's a consolidated school district where students are coming from an hour and a half or 2 hours away, you can't have the same kind of solution as you would in, say, Ottawa, where kids are coming maybe on city buses, you know, from a half hour away. And so it's really, you know, if you think about it, it gets so complex. But again, for me, the bottom line is let them sleep. Let them sleep. However you can manage it, wherever you are, let them sleep.
Thank you. Anyone else with a question for Mary?
So who do we think this is who's driving in the dark? This must be out west somewhere.
I don't know who Nicola is.
Are you
my-
all still on summertime, or have you shifted?
Yeah, no, well, at least on the East Coast we are, but might be less distracting if he would turn off his camera. I guess all of us are concerned about his driving.
Yeah, well,
Well, anyway, I think this comes to an end now, and I want to thank you very much, Mary, for taking the time to give us this lecture and for these answering some of our questions. It's really appreciated, and thank you very much.